Hello everybody, welcome back to another video. I'm sincerely sorry for not being able to upload in a while. I've been studying a lot, doing many things, learning lots of math, and new videos are expected as I've been learning a lot of math, trigonometric integrals, exponential integrals. I've been really getting the hang of working with derivatives and trigonometry, which is this video. Trigonometry is really important in Algebra 1, Geometry in Algebra 2, and also Calculus, as you will be working with trigonometric integrals. I've done a lot of them, and I can guarantee you it's really fun, but it gets tricky, and I'll be uploading a trigonometric integral video on that. I would highly recommend watching this video about trigonometry. You learn the 6 terms, and it's really going to drive trigonometric integrals, as many rules. The Pythagorean theorem will come in, substitution using the Pythagorean theorem with trigonometry, using the Pythagorean theorem to prove that sine squared x plus cos squared x equals 1. I know it's pretty complicated, but I'll explain that in that video. Today we're going to be talking about trig. Now, trig is just a short for trigonometry. Now, I'm sorry I'm using a different whiteboard right now, as I had to divert a little bit. Anywho, let's continue. Trigonometry, sine, cosine, tangent. Now, these are just the first 3. Now, these first 3 will drive the other ones, as, for example, secant is just 1 over sine. So let's take a look at these first. I'm going to put all of them down. I think this is that, cosecant, and then cotan. These are all short versions of that. Now, let's get into trigonometry. So we're going to first start with sine. So sine. Every trigonometric thing is involved with right triangles. So if you have a right triangle, you use trigonometry, and some questions will definitely come in handy, such as finding, angle measures, trigonometric ratios, which is what we're talking about today, and many other things that I have yet to discover. So let's take a look here. So I'm going to draw an easy right triangle, 45, 90, 45, 45. I didn't put the degree thing, but it's fine. So this is going to be easy. This is going to just be a 4, 3, 5, just like so. Now, let's take, I actually do not want to, don't want to do that. I actually don't want to write those angles, because there's a reason to do that. And I'll show you. Just give me 1 second. So, I'm sorry. Been a little floppy, I haven't uploaded in a while. So we're going to call this angle theta, just like so. 4, 3, and 5, right? Easy enough. Four, 3, 5. Now, what if I was trying to find the sine of theta? What would that equal? Now, first we have to understand what sine is. Sine is opposite over hypotenuse. This is a short. Now you can see why you can only use right triangles as hypotenuse, or the longest side technically. Now, whenever we want to find the sine of theta, we're trying to find the opposite and the hypotenuse of theta. So the easiest one. What's the hypotenuse of theta? 5. What is the opposite? So the opposite let's take a look here. We're going to go from the angle, and we're going to reach 4, right? So that means the opposite of theta is 4. That means the sine of theta is 4/5. Easy as that. Now these are really, really basic, but sooner or later we'll get into complicated. So now, cosine. I'm going to draw the same 4, 3, 90 degrees. We're going to call this angle theta again. Let's find the cosine of theta. Now, cos is just short for cosine. Cosine is a little, it really depends on how you approach it. Sine for me is the easiest. So, cosine is just adjacent over hypotenuse. Now, after you use this as well, it'll come to memory because I have memorized all of them. So, let's find the hypotenuse, 5. Now, adjacent. So, the adjacent of theta is not opposite, but it's the side it's sitting on. So, that, in this case, it would be 3. So, it's 3. That means the answer is 3/5. Easy as that. Let's find the tangent. I'm going to draw the same triangle theta. Put 4, 3, 5. Tangent is a little different than the rest because it doesn't include hypotenuse, but it does include adjacent and opposite. So let's find the tangent of theta. Now, tan is the short for tangent, and this is opposite over adjacent. Sorry, that does not look good at all. Sorry about that. Now, let's find the opposite of theta. So, the opposite, we're going to go 1, 2, 3. That's 4. And then the angle, the side it's sitting on, not the hypotenuse, is 3. So this is going to be 4/3. Easy as that. So, we're going to get into the ones that really depend on sine, cosine, and tangent. So, now these are easier if you understand sine, cosine, and tangent. So, let's start with cosecant. We're going to draw the same triangle, as this always has to do with right triangles. It doesn't matter, 30, 60, 90, 45, 90, 45. Doesn't matter. It just has to be a right triangle with a hypotenuse, where a squared plus b squared equals c squared is more rather true. So we're going to call this angle theta. So now let's find the cosecant. These short terms, I'm not quite sure if they're true. I'm pretty sure they are. They probably are. So the cosecant of theta. So, yes, let me draw my sides. Sorry. 4, 3, 5. So, cosecant of theta. So let's talk about what cosecant. So cosecant, if you notice, it has secant and then cosine. So it means this is the cosecant. So we know that cosine is adjacent over hypotenuse. Now this is just 1 over cos. That's basically what it is. That means this equals the reciprocal of cosine. What is that, you ask? So if it's adjacent over hypotenuse, it would be hypotenuse over adjacent. And this goes for all these types of terms that are dependent on cosine, sine, and tangent. So let's find the cosecant of theta. Hypotenuse is 5. Adjacent to this angle is 3. 5/3. Easy as that, right? Secant. Let's try the same triangle. Theta, 3, 4, 5. Let's find the secant. Sorry, secant of theta. So, we know that sine is opposite over hypotenuse, and this is equivalent to 1 over sine, which then equals the reciprocal of sine, which is just hypotenuse over opposite. So, let's find the hypotenuse. It's 5 over opposite. 1, 2, 3, 4. Answer is 5/3. So not 5/3, 5/4. Let's continue. Last one, but not least, cotangent. So we will draw a triangle. So gosh, that does not look like a triangle at all. So I'm gonna label our sides. 3, 4, 5. Let's find the cotangent of theta. So tangent is just going to be 1 over tan, which then equals the reciprocal of tangent, which is adjacent over, and the tangent is just adjacent over, opposite over adjacent. So I mean this equals adjacent over opposite. So the opposite of theta is 4. The adjacent of theta is 3. 3/4. The cotangent of theta is 3/4. So I hope you enjoyed that video. Thank you so much for watching. I'm sincerely sorry that I'm going to be uploading in a while. I might be a little slower in July and August, but I'll still be uploading. So I hope you enjoyed, and thank you so much for watching. As always, enjoy math.